Hello, this is Mr. Collier, and today we're finding the surface area of prisms. First example we have today is called a rectangular prism or a cuboid. It has 6 rectangular faces. Okay, so we're going to draw the net first, which is going to help us find the surface area. So we're going to draw the net first and then find the surface area. So if I were to draw the net, I'm going to start with the bottom face, which is a 7 by 15 rectangle. So let me draw that, or draw a sketch of that. That's a 7 by 15 rectangle. And notice in the front we've got a 15 by 6 rectangle, so we can extend that there. That's a 15 by 6 rectangle. Okay. On the side we've got a 6 by 7 rectangle, another 6 by 7 rectangle on the side. So we've got those two little rectangles over there. 6, 6, that's 7, that's 6, 7, that's 6, that's 6. In the back we've got a 6 by 15 rectangle. Okay. And on the top here, we're going to have a 7 by 15 rectangle. Okay, so we've got the 6 faces. Okay, notice we've got 2 7 by 15 rectangles. We've got 2 6 by 15 rectangles. And we've got 2 6 by 7 rectangles. Okay, so this total surface area, we're going to add up all these areas together. So the surface area is going to be, well, we got 2 red rectangles, those are 6 by 15s. We've got 2 green rectangles, which are 6 by 7s. And we've got those 2 blue ones, which are 7 by 15s. Okay, so we're just going to do this calculation now. 2 times, well, I'll do 15 first. 2 times 15 is 30, times 6 is 180. 2 times, well, this is 6 times 7, that's 42, so 2 times that is 84. 2 times 15 is 30, times 7 is 210. Okay, and I add these together, I'm going to get 474 square meters. Don't forget your units. Surface area is an area, so it is in square units. It's in square centimeters. So that's the surface area of this cuboid. We're going to go on to a triangular prism this time because the bases are triangular. You got 2 triangular faces, and the other 3 faces are rectangles. So firstly for this one, we're going to get the area of one of those triangles. And the area is just going to be half times base times height, which is half, and the base is 12, the height is 9. So we can do that. Half of 12 is 6 times 9. We get 54. Okay, now that's the area of one of those triangles. Later we'll have to multiply by 2 because there's 2 triangles, so let me just put that reminder in there. Okay, now let's look at the rectangles. There's 3 of them altogether. On the bottom we've got a 10 by 12. Okay, so we have 10 by 12 rectangle. That's 10 times 12 equals 120. The area of that rectangle is 120. We also have a 9 by 10, right? That's 10. 9 by 10 rectangle. So the area equals 9 times 10. Area equals 90. That's for our second rectangle. And then we've got this rectangle here is 10. And do we know this side? We do not know this side. We do not know that. That's x, and that's also x. We don't know this distance. Okay, so we need to find out that somehow. And notice that this side here is the hypotenuse of a right triangle, so we can calculate it using the Pythagorean theorem. Okay, so x, so the Pythagorean theorem states that the hypotenuse squared equals the sum of the squares of the legs. So we're going to have x squared equals 9 squared plus 12 squared. X squared equals 81 plus 144. X squared equals 225. And to get the answer, to get the value of x, we're going to take the square root of 225, which equals 15. So x is 15, and now we know what our rectangle measurements are. It's a 10 or 10 by 15 rectangle, right? So the area is going to be 10 times 15, and the area is 150. Okay, so that's the area of the last rectangle. We need to add all these areas together to get the surface area. We do that down here in blue. So we have area equals, and the triangles were 54, so we're going to do 54 times 2 because there's 2 of them, plus 120, plus 90, plus 150, and we're going to work that out. 2 times 54 is 108, plus this is going to be 210, this 120 plus 90 is 210, plus 150 is 360, and add that together, you're going to have 468, and again that's going to be in square centimeters. Okay, so your answer is in square centimeters because surface area is also an area.